Close your eyes and let me take you somewhere extraordinary tonight. Somewhere that will challenge almost everything you think you know about the ancient world, about what a jungle is, about what a civilization looks like, and about how human beings can reshape an entire continent without anyone noticing for 500 years. I want you to imagine that you are standing at the edge of the Amazon rainforest. Not the Amazon you have seen in documentaries, not the pristine, untouched wilderness that explorers have been rhapsodizing about since the 16th century, but the real Amazon. The Amazon as it actually is and as it has been for thousands of years. A landscape so thoroughly shaped by human hands that calling it a wilderness is not just inaccurate. It is one of the biggest misunderstandings in the entire history of science. The air around you is warm and heavy with moisture, the kind of humidity that wraps around your body like a second skin and makes every breath feel thick and substantial. The sounds are extraordinary, a wall of noise that hits you from every direction, the buzzing of insects, the calls of birds you cannot see hidden somewhere in the canopy above, the distant shriek of a howler monkey carrying across the treetops like a warning or a welcome, you cannot tell which. The smell is overwhelming, a rich complex perfume of decomposing leaves and flowering plants, and damp earth, and something sweet, almost fruity, that you cannot quite identify. The light filtering through the canopy above is green and golden, broken into 1,000 shifting patterns by the leaves that move constantly in the faint breeze that somehow reaches down here from the sky you can barely see. You reach out and touch the trunk of a nearby tree, and your fingers find bark that is rough and deeply furrowed, alive with tiny lichens and mosses, and, if you look closely, a column of leafcutter ants marching in a perfect line up the trunk, each one carrying a bright green fragment of leaf held above its head like a tiny parasol. The ants are heading to their nest, a vast underground complex that may extend 10 feet below the forest floor, housing millions of individuals organized into castes as specialized and as efficient as any human society. The ants are farmers. They carry the leaf fragments into their nest, not to eat them, but to cultivate a fungus that grows on the decomposing leaves, a fungus that the ants tend and harvest and feed to their larvae. The leafcutter ants of the Amazon invented agriculture 50 million years before human beings existed. The forest is teaching you something, if you're willing to listen. It is teaching you that the line between nature and cultivation, between wild and managed, between untouched and designed, is far blurrier than you might imagine. Everything in this forest is connected. Everything is part of a web of relationships so complex that no single mind, human or otherwise, can hold it all at once. And the people who lived here for thousands of years understood this. They did not stand apart from the web. They were part of it. They were one of its most active and creative nodes, shaping the web even as the web shaped them, changing the forest even as the forest changed them, until the boundary between human culture and natural ecology became so thin, so permeable, so seamless that one could not be distinguished from the other. This is the Amazon, the largest tropical rainforest on Earth, an area roughly the size of the continental United States, stretching across 9 countries in South America, containing approximately 10% of all the species on the planet, producing roughly 20% of the world's oxygen, holding more fresh water than any other river system anywhere on Earth. And for centuries, the story that Western science told about this place was simple and elegant and almost entirely wrong. The story went like this. The Amazon rainforest is a primeval wilderness, one of the last great untouched landscapes on Earth. It has existed in more or less its current form for millions of years, a vast cathedral of nature undisturbed by human activity. The few people who lived here before European contact were small scattered bands of hunter-gatherers, primitive peoples who adapted to the forest but never significantly altered it. The jungle was too harsh, the soils too poor, the environment too hostile for any kind of complex civilization to develop. Unlike the fertile river valleys of Mesopotamia or Egypt or China, the Amazon offered no foundation upon which cities or kingdoms could be built. It was a green hell, beautiful but barren, teeming with life but incapable of supporting anything more sophisticated than small nomadic bands living at the mercy of the forest. That story is wrong. Not partially wrong, not slightly exaggerated, not a reasonable simplification of a complex reality. It is fundamentally, dramatically, astonishingly wrong. And the evidence that proves it wrong has been accumulating for decades, hidden in the soil beneath your feet, in the composition of the forest around you, in satellite images taken from space, in laser scans that can see through the canopy to reveal what lies beneath, in the genetic signatures of plants that have been quietly telling anyone who would listen that they were domesticated by human hands thousands of years ago. Tonight, as you settle deeper into comfort and let the tension drain from your muscles and the noise of your modern world fade into the background, let me tell you the real story of the Amazon. The story of the people who did not just live in this forest. They built it, they designed it, they engineered it on a scale so vast that we are only now beginning to comprehend what they accomplished. And I promise you, by the time we're done, you will never think about jungles, or civilizations, or the meaning of the word wilderness the same way again. Let us start with the soil, because the soil is where the first and perhaps most important clue was hiding in plain sight for centuries. If you were to dig a hole in a typical patch of Amazonian rainforest, you would find something disappointing. The soil is thin and acidic and poor in nutrients. A rusty reddish clay called oxysol that has been leached by millions of years of tropical rainfall until almost all of its minerals have been washed away. This is one of the main reasons that scientists long believed the Amazon could not support complex societies. The soil simply could not produce enough food. When modern farmers clear patches of rainforest for agriculture, the crops grow well for a year or two, fed by the thin layer of nutrients released by the burning of the forest vegetation. But within a few seasons, those nutrients are exhausted, the soil degrades, and the farmers must move on and clear a new patch. It is a cycle of slash and burn that leaves behind degraded land that takes decades or centuries to recover. For decades, this argument was championed by the archaeologist Betty Meggers, who published an influential paper in 1954 arguing that the Amazon basin was a counterfeit paradise, a landscape whose apparent lushness masked a fundamental inability to support complex societies. Meggers's argument was elegant and persuasive. She pointed to the poor soils, the seasonal flooding, the intense heat and humidity, the prevalence of tropical diseases, and the difficulty of storing food in a climate where everything rots within days. She argued that the Amazon imposed an environmental ceiling on cultural development, limiting societies to small, mobile, egalitarian bands that could never accumulate the surplus food necessary to support craft specialization, social stratification, or monumental architecture. Meggers's counterfeit paradise thesis dominated Amazonian archaeology for decades. It became the standard textbook explanation for why the Amazon seemed to lack the kind of complex societies found in other parts of the Americas. And it was reinforced by the observations of ethnographers who studied the small, scattered indigenous communities that survived in the Amazon in the 20th century. These communities, reduced to a fraction of their pre-contact population by centuries of disease, slavery and displacement, did indeed live in small bands with simple material culture. They seemed to confirm Meggers's theory. But they were not evidence of what Amazonian societies had always been. They were evidence of what was left after 90% of the population had been destroyed. The challenge to Meggers's thesis came from several directions simultaneously. The archaeologist Anna Roosevelt, working at sites along the Amazon mainstream in the 1980s and 1990s, found evidence of dense populations, intensive agriculture, and elaborate material culture at sites like Marigot Island and Santarem that directly contradicted the counterfeit paradise model. Roosevelt's excavations revealed deep middens, accumulated deposits of refuse and food waste that indicated centuries of continuous occupation by large settled communities. She found elaborate pottery, monumental earthworks, and evidence of intensive farming that could not be reconciled with the idea that the Amazon was incapable of supporting complex societies. The debate between Meggers and Roosevelt was fierce and sometimes acrimonious, dividing the field of Amazonian archaeology into opposing camps for years. But as the evidence accumulated from terra preta studies, from LiDAR surveys, from genetic analyses of domesticated plants, from satellite imaging, from the painstaking work of hundreds of researchers across multiple disciplines, the balance shifted decisively against the counterfeit paradise model. The Amazon was not a counterfeit paradise. It was a real one, a paradise created by human ingenuity and maintained by human labour, a paradise that collapsed not because the environment could not support it, but because the people who had created it were killed by diseases they had never encountered and could not resist. The poor soil seemed to prove the point. No soil, no agriculture, no cities, no civilization. Case closed. Except that scattered throughout the Amazon basin, in patches that range from a few acres to hundreds of acres in size, there is another kind of soil, a soil so different from the surrounding oxysol that it seems almost miraculous by comparison. This soil is deep and black and rich, incredibly fertile, capable of producing abundant harvests year after year without degradation. It is so distinctive that the local people have a name for it. They call it Terra Preta de Indio, Black Earth of the Indians, and when scientists finally began studying Terra Preta seriously in the late 20th century, what they discovered turned everything upside down. Terra Preta is not natural. It was made. It was manufactured by human beings, deliberately and skillfully, over a period of thousands of years. The black colour comes from charcoal, enormous quantities of charcoal mixed into the soil along with organic matter, pottery fragments, bone, manure and other materials. The charcoal is the key. Unlike ordinary organic matter which decomposes quickly in the hot humid conditions of the tropics, charcoal is extraordinarily stable. It persists in the soil for thousands of years, and while it persists, it does something remarkable. It acts as a sponge for nutrients, trapping them in its porous structure and preventing them from being washed away by the relentless tropical rains. It also provides habitat for beneficial soil microorganisms that further enhance fertility. The result is a soil that is not just fertile but self-renewing, a soil that actually regenerates itself over time as the charcoal and the microbial communities continue to function long after the people who created them have gone. Some Terra Preta deposits are more than 7,000 years old, and they are still more fertile than the surrounding natural soil. Think about that. 7,000 years ago, someone figured out how to transform one of the poorest soils on Earth into one of the richest, and the transformation is still working today. That is not primitive. That is not simple. That is one of the most sophisticated pieces of environmental engineering in the entire history of human civilization. Let me take you to one of these Terra Preta sites, so you can understand what it feels like to stand on this extraordinary soil. You're in the central Amazon, along a bluff overlooking a wide brown river that moves slowly beneath you, carrying the silt of a continent toward the distant Atlantic. The forest presses in from every side, a wall of green so dense and so tall that it feels like standing at the bottom of a living canyon. You kneel and push your fingers into the ground, and immediately you feel the difference. This is not the hard, rusty clay of the surrounding forest. This soil is soft and crumbly, almost spongy, dark as chocolate and rich with the unmistakable earthy smell of fertile ground. You can feel fragments in the soil, tiny pieces of pottery, so small they are almost like grains of sand, mixed in with flecks of charcoal and bits of bone so old they crumble at your touch. This is Terra Preta, and you are kneeling on a spot where people lived and worked and ate and loved and buried their dead for century after century after century. The depth of the deposit beneath you may be 2 feet or 3 feet, or in some places as much as 6 feet of accumulated human-made soil, each inch representing years of habitation, each layer a record of meals cooked and refuse composted and fires tended and gardens cultivated. Modern soil scientists have studied Terra Preta with every tool available to them, from chemical analysis to electron microscopy to DNA sequencing, and what they have found is nothing short of remarkable. The charcoal in Terra Preta is not just any charcoal. It is produced at specific temperatures between 300 and 500 degrees Celsius that create a form of carbon called biochar that is maximally porous and maximally stable. This suggests that the ancient Amazonians were not simply burning their garbage. They were producing charcoal deliberately, using controlled low-temperature fires that converted organic waste into the specific form of carbon best suited for soil amendment. They were, in effect, manufacturing a soil additive, a product designed to transform poor tropical soil into permanently fertile agricultural land. The pottery fragments mixed into the soil are not accidental either. Archaeologists have found that Terra Preta soils contain 10 to 80 times more ceramic material than surrounding natural soils. Some researchers believe that the pottery was intentionally broken and mixed into the soil because the porous ceramic material, like the charcoal, served as a habitat for beneficial microorganisms and a reservoir for nutrients. Others suggest that the pottery fragments simply accumulated over centuries of habitation and were incorporated into the soil as part of the general composting process. Either way, the presence of so much ceramic material tells us that these were settled communities, people who lived in one place long enough to generate enormous quantities of pottery and to transform the very ground beneath their feet. The microbiology of terra preta is perhaps the most fascinating aspect of all. The soils contain communities of microorganisms that are distinctly different from those found in surrounding natural soils. These microbial communities appear to be self-sustaining, maintaining themselves and even expanding over time without any human input. Some researchers have described terra preta as a living soil, an engineered ecosystem that continues to function and even improve thousands of years after its creators abandoned it. There is even evidence that terra preta soils can regenerate themselves. Farmers in the modern Amazon have reported that when they remove terra preta from a site and use it elsewhere, the original site regenerates new terra preta within a few decades, suggesting that the microbial communities in the charcoal matrix work together to continuously produce new fertile soil from the raw materials available in the tropical environment. If this is true, and the evidence is increasingly compelling, then the ancient Amazonians did not just create fertile soil. They created a self-perpetuating soil-making machine, a biological technology that continues to operate autonomously thousands of years after its inventors are gone. And terra preta is everywhere. Not literally everywhere, but it is scattered across the Amazon basin in thousands of individual deposits, concentrated along rivers and streams, but also found in upland areas far from any major waterway. The total area covered by terra preta is estimated at somewhere between 6,000 and 18,000 square miles, roughly 1 to 3% of the total Amazon basin. And every single patch of it was made by human hands. Every single patch represents a place where people lived, where they gardened and cooked and processed food and managed waste and, whether intentionally or as a byproduct of their daily activities, created a new kind of soil that would outlast their civilization by millennia. But terra preta was just the beginning. The soil was the foundation upon which something much larger was built. Because the people who created terra preta were not just improving the soil, they were transforming the entire forest. Let me explain what I mean by that, because it is one of the most extraordinary revelations in the history of ecology. For a long time, scientists assumed that the species composition of the Amazon rainforest was determined by natural processes, by the interplay of climate and geology and evolution over millions of years. The distribution of tree species, the patterns of biodiversity, the structure of the forest, all of this was thought to be the product of nature alone, with no significant human influence. Then, in 2017, a team of researchers published a study that changed the conversation entirely. They analysed the distribution of tree species across the Amazon basin, comparing areas near known archaeological sites with areas far from any evidence of human habitation. What they found was stunning. In areas near archaeological sites, certain tree species were dramatically overrepresented compared to what you would expect from natural processes alone. And these were not random species. They were domesticated or semi-domesticated species, trees and plants that produce food that humans eat. Brazil nut trees, cacao trees, acai palms, tucuma palms, pupuna palms, rubber trees, cashew trees, dozens of species that provide fruits, nuts, oils, medicines, fibers, and other products useful to human beings. The study, published in the journal Science in 2017 by a team led by Carolina Levis, and involving more than 100 researchers from institutions around the world, analysed data from more than 1,000 forest plots scattered across the Amazon basin. The researchers looked at what are called hyperdominant species, the roughly 227 tree species that together account for more than half of all individual trees in the Amazon, despite representing only about 1.5% of the total number of species. In other words, out of 16,000 tree species, a tiny fraction dominates the forest in terms of sheer numbers. And when the researchers mapped the distribution of these hyperdominant species against the locations of known archaeological sites, the correlation was unmistakable. 85 of the hyperdominant species are known to have been domesticated or managed by humans, and these 85 species are significantly more abundant and more dominant near archaeological sites than in areas far from human habitation. The effect is not subtle. In some areas, the forest near ancient settlements is composed almost entirely of species that were promoted by human management, species that produce edible fruits, useful fibers, valuable oils, or medicinal compounds. The forest is essentially an abandoned orchard, still producing the fruits and nuts that its planters intended, still organised according to the patterns that human hands imposed upon it centuries ago. The researchers estimated that at least 20% of the Amazon's tree communities have been significantly influenced by past human activity. Some estimates go much higher. In the eastern Amazon, where human occupation was most dense and most prolonged, the figure may be closer to 50% or more. The implications are profound. They mean that the Amazon is not a natural baseline against which human impact can be measured. The Amazon is itself a product of human impact. The forest that we see today, the forest that we are trying to preserve, is not the forest that existed before humans arrived. It is the forest that humans created, and understanding this is essential for effective conservation, because if we try to preserve the Amazon by excluding all human activity, we may actually be undermining the very processes that created and maintained the forest's extraordinary diversity in the first place. These species were up to 5 times more common near archaeological sites than in areas without evidence of human habitation. The forest itself, the supposedly pristine, untouched wilderness, bore the fingerprints of thousands of years of human management. The ancient Amazonians had not just gardened small plots. They had gardened the forest itself, selectively promoting useful species, clearing space for them, protecting them from competition, gradually transforming the species composition of millions of acres of tropical forest to make it more productive for human use. The Amazon rainforest is not a wilderness, it is a garden, the largest garden ever created by human beings. A garden so vast and so cleverly designed that for 500 years after its gardeners were killed by European diseases, scientists looked at it and saw only nature. They did not see the human hand because the human hand had worked so subtly, so harmoniously with the natural processes of the forest, that the result looked natural. It looked like wilderness. It looked like something that had always been there. But it had not always been there. It had been planted, tended, managed, designed, by people whose understanding of tropical ecology was so profound that their creation fooled the world's best scientists for half a millennium. Now, I want to take you deeper into this story, literally deeper, beneath the canopy of the forest to a part of the Amazon that most people have never heard of. The Llanos de Mojos, the Mojo's Plains, a vast seasonally flooded savanna in the Beni department of northeastern Bolivia. This is not thick jungle. This is grassland, flat as a table and stretching to the horizon in every direction, green and waterlogged during the rainy season from November to April, brown and parched during the dry season from May to October. It is not a place where you would expect to find the remains of a great civilization. But in the 1960s, a geographer named William Denevan was flying over the Llanos de Mojos in a small airplane when he noticed something strange. The flat grassland below was not featureless. It was covered with geometric patterns, raised causeways running in straight lines for miles across the floodplain, rectangular raised fields arranged in enormous grids, circular mounds rising above the level of the seasonal floods, each one large enough to support a village, canals connecting the mounds to the causeways and the causeways to the rivers, fish weirs built into the channels to trap fish during the seasonal floods. The landscape was engineered. The entire plain, as far as Denevan could see from the air, had been reshaped by human activity on a scale that was almost incomprehensible. Subsequent research has confirmed and expanded upon Denevan's initial observations. The Llanos de Mojos contains thousands of raised mounds called lomas, scattered across the floodplain. Some of these lomas are small, only a few meters across, but others are enormous, covering several hectares and rising 5 or more meters above the surrounding plain. They are artificial islands, built up over centuries by the deliberate deposition of earth, refuse and organic matter, creating dry habitable platforms in a landscape that spends half the year underwater. The raised fields are equally impressive. Archaeologists have documented tens of thousands of them, rectangular platforms of earth separated by channels that served as both drainage ditches and fish ponds. During the rainy season, when the floodwaters covered the plain, the raised fields remained above water, allowing crops to be grown even during the wettest months. During the dry season, the channels retained water, keeping the soil moist and the fish alive. It was an ingenious system of water management that turned a marginal environment into one of the most productive agricultural landscapes in South America. And connecting all of these features were the causeways, raised earthen roads that crisscrossed the plains in straight lines for distances of up to 20 miles, linking the inhabited lomas to each other, to the rivers, and to the surrounding forest. Some of these causeways were wide enough for several people to walk abreast, and they were built above the flood level, ensuring year-round access between communities even during the wettest months. But the causeways and raised fields are only part of the story. The Llanos de Mojos also contains one of the most remarkable features of the entire Amazon, the forest islands. Scattered across the open grassland of the Mojos Plains are approximately 4,700 small patches of forest, each one rising slightly above the level of the surrounding savanna on a low mound of dark, fertile soil. For a long time, scientists assumed these forest islands were natural features, remnants of a once larger forest that had been reduced to scattered fragments by climate change or fire. But when researchers began studying the islands more carefully in the 2010s, they discovered something astonishing. The soil beneath the forest islands is terra preta. The mounds on which the islands sit were built by human beings, and the tree species that grow on the islands are not random. They're overwhelmingly useful species, fruit trees and nut trees and palm trees, the same domesticated and semi-domesticated species that characterize ancient managed forests throughout the Amazon. The forest islands of the Llanos de Mojos are orchards, 4,700 orchards planted on human-made mounds of enriched soil, scattered across the grassland like green jewels on a golden cloth. Some of them were established more than 10,000 years ago, making them among the oldest evidence of plant cultivation anywhere in South America. Let me paint a picture of what life on the Llanos de Mojos might have looked like at its peak, perhaps around 1000 AD. Imagine you are standing on one of the larger lomas, an artificial island about 300 feet across and rising 15 feet above the surrounding floodplain. It is the middle of the rainy season, and the world around you is water. The grassland has disappeared beneath a shallow lake that stretches to the horizon in every direction, brown and warm and teeming with fish. But you are dry. Your island rises above the flood, its surface packed earth that generations of your ancestors have built up, layer by layer, over centuries. On the highest part of the island, 3 large communal houses stand in a rough semicircle around a central plaza. The houses are built of wooden poles and palm thatch, their roofs steeply pitched to shed the torrential rain, their interiors dark and cool and smelling of wood smoke and dried fish. Around the edge of the island, a ring of fruit trees provides shade and food. Peach palms heavy with clusters of orange fruits, cacao trees with their cauliflorous pods growing directly from the trunk, avocado trees, guava trees, papaya trees laden with heavy fruits hanging like green lanterns from their slender trunks. Between the trees, small garden plots are planted with manioc and sweet potatoes and maize, their roots sinking into the rich terra preta soil that your ancestors created. The water that surrounds your island is not empty, it is managed. Channels dug between the raised fields direct the flow of water through a network of ponds and weirs designed to trap fish. During the flood season, fish from the rivers spread across the inundated grassland to feed and breed, and the weirs capture them as the waters recede, funneling them into ponds where they can be easily harvested. The raised fields themselves, their surfaces just above the waterline, are planted with crops that thrive in the moist conditions, and the nutrient-rich sediment deposited by the floodwaters fertilizes them naturally each year. It is an integrated system of stunning elegance. The floods that would devastate a conventional farming community are not a problem here. They are a resource. They bring fish, they bring nutrients, they bring water for the dry season. The raised fields and causeways and canals and weirs transform the annual flood from a destructive force into the engine that drives the entire agricultural system. When the dry season comes, the water recedes, the grassland reappears, and the landscape transforms again. The canals and reservoirs retain water for irrigation and for fish, keeping the ponds stocked and the gardens watered through the months when no rain falls. The causeways, now dry, serve as highways connecting the inhabited lomas to each other and to the surrounding forests, where people gather wild foods, hunt game, and manage the forest islands that produce much of their fruit and nut supply. The fish farming is particularly ingenious and deserves a closer look. The people of the Llanos de Mojos did not just catch wild fish. They managed fish populations with the same deliberate intelligence that they applied to every other aspect of their environment. The channels between the raised fields served as fish ponds stocked with species that thrived in the warm, shallow water. As the annual floods receded, fish that had spread across the inundated plain were funneled through the canal system by carefully placed weirs, V-shaped barriers of stakes and woven mats that directed the flow of fish toward collection points where they could be easily netted or speared. Some of the weirs were hundreds of feet long, spanning the width of natural drainage channels and capturing enormous quantities of fish. Archaeologists have found the remains of large smoking and drying racks near the weirs, evidence that the fish catch was processed and preserved in quantities far exceeding the immediate needs of the local community, suggesting that dried fish was a trade commodity, exported to communities in other ecological zones in exchange for forest products, pottery, textiles, or other goods. The integration of agriculture and aquaculture in a single landscape is a hallmark of Amazonian engineering genius. The raised fields produced crops while the channels between them produced fish. The decaying plant matter from the fields fell into the channels and fed the algae and microorganisms that the fish ate. The fish waste in the channels provided nutrients that were absorbed by the raised field crops. It was a closed-loop system, a circular economy operating at a landscape scale, in which the waste products of one component became the inputs for another, minimizing loss and maximizing productivity. Modern aquaculture engineers are only now beginning to develop integrated systems that approach the elegance and efficiency of what the Mojo's people achieved with nothing more than earth, water, stakes, and woven mats. The Mojo's people moved through their landscape with the seasons, adapting their activities to the rhythm of flood and drought, using the engineered landscape to buffer themselves against the extremes of the tropical climate. It was not a simple life. It was a sophisticated one, requiring deep knowledge of hydrology, ecology, soil science, and agricultural engineering, knowledge accumulated over thousands of years and passed from generation to generation through oral tradition and practical apprenticeship. The total length of causeways documented in the Llanos de Mojos runs to thousands of miles of raised roads built by hand in a landscape that most people would consider uninhabitable. Now let me take you to another part of the Amazon story, one that has emerged only in the last few decades thanks to a technology that has revolutionized archaeology worldwide. The technology is called LiDAR, which stands for light detection and ranging. It works by firing millions of laser pulses from an aircraft toward the ground and measuring the time it takes for each pulse to bounce back. Because some laser pulses pass through gaps in the forest canopy and reach the ground below, LiDAR can effectively see through the trees, creating a detailed three-dimensional map of the ground surface beneath even the densest forest cover. When LiDAR was first applied to the Amazon in the 2000s, the results were nothing short of revolutionary. In the Xingu region of southern Brazil, LiDAR scans revealed the remains of a network of settlements connected by roads and surrounded by managed landscapes that covered an area of approximately 7,700 square miles. The settlements were not random or haphazard. They were organized in a distinctive pattern that archaeologists call a galactic cluster, with larger central settlements surrounded by smaller satellite communities arranged in a roughly circular pattern, all connected by wide, straight roads that radiated outward from the center like the spokes of a wheel. The central settlements contained large circular plazas, some of them hundreds of feet in diameter, surrounded by concentric rings of houses and gardens. The roads connecting the settlements were remarkably uniform, about 30 feet wide, perfectly straight, and flanked by low earthen berms. Some of these roads extended for miles through the forest, connecting settlements that were otherwise invisible from each other, and possibly many more. The archaeologist Michael Heckenberger and his colleagues, who conducted much of the groundbreaking research in the Upper Xingu, described what they found as garden cities, a term borrowed from the early 20th century urban planning movement that envisioned cities surrounded by green belts and gardens rather than sprawling suburbs. The Xingu garden cities were organized according to principles that no Western urban planner had ever imagined. Each settlement was built around a central circular plaza, a large open space that served as the social and ceremonial heart of the community. The houses were arranged in a ring around the plaza, facing inward, so that every dwelling had a view of the communal space. Beyond the ring of houses, concentric zones of land use radiated outward, each zone serving a different purpose. The innermost zone, immediately behind the houses, contained small kitchen gardens, where families grew herbs and fast-growing vegetables for daily use. Beyond the kitchen gardens was a zone of larger agricultural fields where manioc, the starchy root vegetable that was the staple crop of the region, was cultivated in extensive plots along with maize, sweet potatoes and other crops. Beyond the fields was a zone of managed orchard forest, where useful tree species had been encouraged and competitors removed over many generations, creating a park-like woodland that produced fruits, nuts, medicines, and building materials. And beyond the managed forest, the wildest and least modified zone, the forest gradually transitioned back to something closer to its natural state, though even here the influence of human management was detectable in the elevated presence of domesticated species. The roads that connected these settlements were not simple footpaths. They were monumental constructions, perfectly straight, 30 feet wide, flanked by low earthen berms, and sometimes bordered by lines of trees that created a canopy of shade over the road surface. Some of these roads ran for miles through the forest, connecting settlements that could not see each other, maintaining perfect straightness even over uneven terrain. The engineering required to plan and construct these roads was considerable, and the labour involved suggests that the roads were not just practical transportation routes, but also symbolic statements, visible expressions of the connections between communities, physical embodiments of the social and political relationships that bound the network together. Heckenberger was struck by the sophistication of the settlement pattern. The hierarchical organisation, with larger central settlements and smaller satellite communities, suggested a level of political complexity that went far beyond the simple egalitarian band that most Westerners imagined when they thought of Amazonian peoples. There were clearly leaders and followers, central places and peripheral places, more important settlements and less important ones. But the hierarchy was not oppressive or exploitative. It was integrative, designed to coordinate the activities of many communities across a large landscape, managing resources, resolving disputes, organising labour for the construction and maintenance of roads and plazas, and overseeing the ceremonial life that bound the network together. The descendants of the Xingu Garden City builders still live in the Upper Xingu region today. They are the Kwikoro, the Kalapalo, the Wara, and other peoples of the Xingu Indigenous Park. The continuity between past and present in the Upper Xingu is one of the most remarkable things about the region. When Heckenberger first began his archaeological work in the area in the late 1990s, he was guided by Kwikoro elders who led him to sites that their oral histories described as the locations of ancient villages. And sure enough, when Heckenberger excavated, he found exactly what the oral histories predicted: the remains of large settlements with circular plazas, defensive ditches, and road networks that matched the patterns described in Kwikoro tradition. The ancient site of Kuikugu, which the Kwikoro identify as their ancestral home, was a major settlement covering about 50 hectares, surrounded by a deep ditch and embankment that enclosed a central plaza and multiple residential areas. The ditches at Kuikugu and other ancient Xingu sites are impressive engineering works, up to 15 feet deep and 30 feet wide, with the excavated earth piled on the inner edge to create a formidable barrier. Some archaeologists have interpreted these ditches as defensive features, evidence of warfare between competing communities, but others have suggested that they served primarily symbolic and social functions, defining the boundary of the community, separating the cultivated interior from the wild exterior, marking the transition from the social world to the natural world. Whatever their primary purpose, the ditches required enormous labour to construct and maintain, and they tell us that the ancient Xingu communities had the organisational capacity to mobilise hundreds of workers for major construction projects. The Xingu research has also revealed something fascinating about the relationship between ancient and modern settlement patterns. Many of the modern Kwikoro and Kalapalo villages are located on or very near the sites of ancient settlements. The oral traditions that guided Heckenberger to the archaeological sites were not vague folk memories. They were precise geographical knowledge, accurate descriptions of specific locations that had been maintained in oral tradition for 500 years or more, passed from generation to generation with a fidelity that would be impressive in any culture, and that is a testament to the importance that the Xingu peoples place on their ancestral landscape. The modern villages are smaller than the ancient ones, the defensive ditches have not been maintained, the road networks have largely disappeared, but the basic pattern of life, the circular village, the central plaza, the concentric zones of gardens and managed forest, persists. The knowledge has survived, diminished, but not destroyed, a living thread connecting the present to a past that was far richer and more complex than the colonial narrative ever acknowledged. And they still organise their villages around circular plazas and maintain gardens, and manage forests according to principles that their ancestors developed centuries ago. When Heckenberger showed his archaeological maps to his Kwikoro hosts, They recognized the ancient settlement patterns immediately. They knew the old road alignments. They knew where the ancient plazas had been. They carried in their oral traditions the memory of a time when the Upper Xingu was home to a much larger and more complex society than the one that exists today, a society that was devastated by European diseases but never entirely destroyed. The researchers estimated that this network of settlements could have supported a population of 50,000 people or more, living in a carefully organized landscape that integrated gardens, managed forest, aquaculture, and permanent settlements into a sustainable system that functioned for centuries. And the Xingu is just one of many areas where LiDAR has revealed the hidden remains of ancient Amazonian societies. In the Acre region of western Brazil, near the border with Bolivia and Peru, LiDAR and deforestation have revealed hundreds of geoglyphs, enormous geometric earthworks carved into the ground that were completely invisible beneath the forest canopy. These geoglyphs are astonishing. Perfect circles, perfect squares, perfect octagons, some of them over 1,000 feet in diameter, connected by straight roads, scattered across an area of more than 5,000 square miles. They look almost exactly like the geometric earthworks of the Hopewell in Ohio, and they were built at roughly the same time, between about 200 BC and 1200 AD. The purpose of the Acre geoglyphs is still debated, but most archaeologists believe they served ceremonial functions similar to those of the North American earthworks. They are too precisely shaped to be defensive structures, and the absence of significant domestic refuse inside the enclosures suggests they were not permanent settlements. They were gathering places, ceremonial centres, locations where people from scattered communities came together for rituals and celebrations, and the renewal of social bonds. Let me take you to one of these geoglyphs, because standing inside one is an experience that stays with you. You are in the state of Acre in western Brazil near the border with Bolivia. The forest has been recently cleared for cattle ranching, a process that is tragically destroying the Amazon at an alarming rate, but that has also inadvertently revealed archaeological features that were invisible beneath the canopy. Before you, cut into the reddish earth, is a perfect circle approximately 1,000 feet in diameter. The ditch that forms the circle is about 30 feet wide and about 15 feet deep, with the excavated earth piled on the inside edge to form a low embankment. The precision is extraordinary. This is not an approximate circle, not a roughly round shape. It is geometrically perfect as anything drawn with a compass, and it was cut from the earth by hand, by people using stone tools and wooden shovels, moving thousands of cubic meters of soil to create a shape that can only be fully appreciated from the air. Inside the circle, the ground is level and clear, a smooth floor of packed earth with no evidence of permanent structures or domestic refuse. This was not a living space. It was a ceremonial space, a place set apart from the ordinary world, marked by its geometry as something sacred and significant. Near the circle, connected by a short straight ditch, is a perfect square of similar dimensions. The combination of circle and square, the union of curved and straight, of organic and geometric, echoes the same symbolic vocabulary found in the Hopewell earthworks of Ohio, though there is no evidence of any direct connection between the two traditions. The parallel is structural, not historical, arising from the universal human impulse to express cosmic ideas through geometric forms. More than 450 of these geoglyphs have been documented in the Acre region alone, and new ones are still being discovered as deforestation continues to expose previously hidden ground. They come in several shapes: circles, squares, octagons, hexagons, ellipses, and more complex forms that combine multiple geometric elements. Some are connected by straight ditched roads. Some occur in clusters, with multiple geoglyphs arranged in patterns that suggest deliberate planning. The labour required to construct them was enormous, comparable to that required for the Hopewell earthworks or the Great Mound complexes of the Mississippi Valley. And here is what makes the Acre geoglyphs particularly significant. The forest that covered them until recently was mature tropical rainforest, indistinguishable from the surrounding virgin jungle. When scientists analysed the soil and the vegetation on the geoglyph sites, they found that the forest had been growing on these sites for hundreds of years, long enough to create a canopy that was essentially identical to the unmodified forest nearby. The geoglyphs were hidden not by some deliberate act of concealment, but by the simple passage of time and the relentless growth of the tropical forest. But here is the crucial detail. When scientists studied the charcoal and pollen records from the geoglyph sites, They discovered that the geoglyphs were originally built in open or semi-open landscapes, not in dense forest. The people who built them had managed the forest in their area, maintaining clearings and open woodlands around their ceremonial sites. It was only after the builders disappeared, after their population was destroyed by European diseases, that the forest reclaimed the land and grew over the geoglyphs, burying them beneath the canopy. The virgin forest that covered the geoglyphs was not ancient. It was secondary growth, only about 500 years old, dating to approximately the time of European contact. The so-called primeval Amazon rainforest that conservationists have been fighting to protect is, in many areas, younger than the cathedrals of Europe. It grew up on land that had been managed by human communities for thousands of years, and that was only abandoned when those communities were destroyed by colonialism and disease. This realization has profound implications for how we think about conservation and sustainability. If much of the Amazon is a managed landscape rather than a pristine wilderness, then the goal of conservation should not be to exclude human activity from the forest, but to restore the kind of human activity that maintained the forest's health and productivity for thousands of years. The ancient Amazonians were not enemies of the forest. They were its partners, its stewards, its gardeners, and the forest thrived under their care in ways that it may not be able to sustain on its own. The geoglyphs tell us something crucial about the people who built them. They tell us that these people had the social organization, the surplus labor, and the engineering knowledge to construct monumental earthworks in the middle of the tropical forest. And they tell us that these people were not isolated. The similarity of the geometric forms across a vast area suggests that the builders of the acre geoglyphs participated in a shared symbolic system, a common vocabulary of shapes and meanings that connected communities across thousands of square miles of forest. The parallels with the Hopewell interaction sphere of North America are striking and probably not coincidental. Both involve geometric earthworks built by societies that are traditionally described as non-urban, non-state, non-hierarchical. Both involve the construction of ceremonial landscapes on a monumental scale. Both suggest that complex societies can emerge and thrive without the centralized political structures that Western scholars have long considered prerequisites for civilization. In 2022, and again in 2024, LIDAR surveys in eastern Ecuador in the upper Amazon region near the Andes foothills revealed something even more spectacular. Beneath the dense jungle canopy, researchers found the remains of a network of cities and towns connected by wide roads, with the largest settlements covering areas of hundreds of hectares. The sites belong to the Upano culture, which flourished between about 500 BC and 300 to 600 AD, and they included large earthen platform mounds arranged around central plazas, residential areas, agricultural terraces, and a road system that connected the settlements into a coherent urban network. The population of this network has been estimated at anywhere from 10,000 to 100,000 people, making it contemporary with and comparable in scale to some of the early urban centers of Mesoamerica. Let me describe what the LIDAR revealed in more detail, because the images that emerged from the data processing are among the most breathtaking in modern archaeology. When the laser pulses penetrated the canopy and mapped the ground surface beneath, the computer screens lit up with a landscape that no one had imagined. Platforms and plazas leaped out of the digital terrain model like the blueprints of a forgotten city. The platforms were rectangular, typically about 50 to 100 feet long and 20 to 30 feet wide, raised several feet above the surrounding ground on bases of packed earth. They were arranged in groups, clusters of platforms surrounding open plazas that were clearly public spaces, gathering places, ceremonial centers. The largest platforms were massive, elevated 10 or 15 feet above the surrounding landscape, their flat tops large enough to support substantial structures. Streets ran between the platform clusters, straight and clearly planned, connecting neighborhoods to each other and to the central plazas, and connecting the settlements to each other, wide roads cut through the forest in straight lines, some of them running for more than 15 miles without deviation. The roads were flanked by ditches and bordered by low embankments, and they maintained their alignment with such precision that they must have been planned and surveyed before construction began. The Upano culture that built these cities flourished at a time when the Roman Republic was still expanding across the Mediterranean, when the Han dynasty was consolidating its power in China, when the Maya civilization was entering its classic period in Central America, These were not late developments, not the products of a culture that had recently achieved sophistication. These were the works of a society that had been developing its urban traditions for centuries, perfecting its architectural vocabulary, refining its landscape management practices, building upon the accumulated knowledge of generations. And the Upano cities were not isolated. They were part of a network connected by roads, linked by shared architectural conventions, unified by common cultural practices. The total area covered by the network extended to at least 300 square kilometres, and the true extent may be much larger, limited only by the amount of forest that has been surveyed with LiDAR so far. Every new survey reveals new sites, new roads, new plazas, new platforms. The map of ancient Amazonian urbanism is growing with every passing year, and there is no sign that we are anywhere close to seeing the full picture. When the LiDAR results from eastern Ecuador were published in the journal Science in January 2024, they made headlines around the world. The Amazon had cities, real cities with roads and plazas and monumental architecture and planned layouts, and all the things that Western civilization had always claimed were the exclusive achievements of the Old World. The headlines were correct, but they were also about 500 years late. The cities had always been there. It was only our ability to see them that was new. These were cities, not villages, not camps, not temporary settlements, but permanent urban centres with monumental architecture and planned layouts and road systems and all the other hallmarks of what we normally call civilization, and they were hidden beneath the Amazon jungle for over 1,000 years, invisible to anyone who did not have the technology to see through the trees. But before I get to the most headline-grabbing discovery, let me tell you about another piece of the puzzle that often gets overlooked. At the mouth of the Amazon, where the great river empties into the Atlantic Ocean, lies Marajó Island. It is the largest fluvial island in the world, roughly the size of Switzerland, a low flat expanse of seasonally flooded grassland and forest, sitting at the apex of the Amazon Delta. Between about 400 and 1300 AD, Marajó was home to the Marajoara culture, one of the most artistically sophisticated societies in the ancient Amazon. The Marajoara built large earthen mounds on the island, some of them over 30 feet high and covering several acres, that served as platforms for their villages and ceremonial centres. They maintained extensive raised field systems similar to those of the Llanos de Mojos, and they produced pottery that ranks among the finest in the ancient Americas, large elaborately decorated urns and vessels painted and incised with geometric and zoomorphic designs of extraordinary complexity. The pottery of the Marajoara features bold patterns of interlocking lines, spirals, faces and animal forms, painted in red, black, white and orange on a buff background. The designs are so intricate and so mathematically precise that some researchers have suggested they encode information, perhaps genealogical or cosmological, in a form that served as a kind of visual language. The burial urns are particularly impressive, large vessels several feet tall, decorated with elaborate modelled faces and geometric patterns that may represent the identity or status of the deceased. When the naturalist Friedrich Katzer first examined Marajoara pottery in the 19th century, he declared that it could not have been produced by Amazonian peoples and must have been imported from the Andes or from Mesoamerica. He was wrong. The Marajoara pottery was produced locally using local clays and local techniques by people whose artistic traditions had developed over centuries of continuous occupation on the island. The assumption that Amazonian peoples were incapable of producing sophisticated art was simply one more expression of the same bias that denied the existence of Amazonian civilization for so long. Further up the Amazon, in the Santarém region where the Tapajós River meets the Amazon mainstream, the Tapajós culture produced ceramic art of even more extraordinary elaboration. Their pottery features three-dimensional figures of animals, humans, and supernatural beings, modelled onto the surfaces of vessels with a virtuosity that suggests a long and sophisticated artistic tradition. Some Tapajós vessels are covered with dozens of individually modelled figures, frogs and birds and snakes and human faces, all arranged in compositions that suggest narrative scenes or cosmological maps. The Tapajós also produce small ceramic figurines called muraquitas, frog-shaped pendants carved from green nephrite jade that were widely traded across the Amazon basin and beyond, found in archaeological sites as far away as the Caribbean coast of Venezuela. The muraquitas are evidence of yet another long-distance trade network in the Amazon, connecting communities across thousands of miles of forest and river, exchanging not just raw materials but finished artistic objects that carried symbolic and spiritual meaning. And let me tell you about the most recent discovery of all, the one that made headlines around the world and forced even the most skeptical scientists to reconsider everything they thought they knew about the Amazon. In the Cotoca and Landivar sites in the Llanos de Mojos of Bolivia, LiDAR surveys revealed the remains of two enormous settlements belonging to the Casarabe culture, which flourished between about 500 and 1400 AD. The larger of the two sites, Cotoca, features a massive conical mound rising about 70 feet above the surrounding plain, topped by a U-shaped platform. Surrounding the central mound is a complex of terraces, platforms, causeways, canals and reservoirs covering an area of several hundred hectares. The engineering is sophisticated and deliberate, with water management systems that channeled seasonal floodwaters through a network of canals and reservoirs, storing water for the dry season and distributing it across the agricultural landscape. Landivar, the second site, is equally impressive, with its own central mound and an extensive system of raised fields and causeways extending for miles in every direction. The two sites are connected by a straight causeway several miles long, and both are linked to a broader network of smaller settlements, raised fields, and causeways that covers an area of over 1,700 square miles. Let me help you visualize what Cotoca might have looked like at its peak, around 1200 AD. You are approaching from the south along one of the straight causeways that connect the site to the broader network. The causeway is raised about 6 feet above the surrounding plain, its surface packed and smooth, wide enough for a dozen people to walk side by side. On either side of the causeway, rectangular raised fields stretch away to the horizon in orderly rows, their surfaces green with crops, the channels between them glinting with water in which fish dart and turn. The air smells of wet earth and growing things and the faint smoke of cooking fires from the settlement ahead. As you draw closer, the landscape begins to change. The flat agricultural plain gives way to a more complex terrain of terraces and platforms, each one a few feet higher than the last, creating a stepped landscape that leads your eye upward toward the central mound, and then you see it. Rising from the centre of the settlement like a small mountain, the great conical mound of Cotoca towers 70 feet above the plain, its sides steep and covered in packed earth that has been smoothed and maintained by generations of careful labour. At its summit, a broad U-shaped platform supports a complex of wooden structures, temples perhaps, or the residences of leaders, or ceremonial spaces whose precise function we can only guess at. Around the base of the great mound, the settlement spreads outward in concentric zones. Nearest the mound are smaller platform mounds that may have served as the residences of important individuals or families. Beyond these, a ring of ordinary houses, their thatched roofs visible above garden plots and fruit trees. Beyond the houses, a sophisticated network of canals and reservoirs manages the flow of water through the settlement, channeling rainwater and floodwater into storage basins that ensure a reliable supply during the dry months. The whole settlement covers several hundred hectares, home to perhaps several thousand people at its peak. It is not a compact city like Rome or Tenochtitlan. The buildings are spread out, interspersed with gardens and orchards, and open spaces and water features. But it is unmistakably urban, a planned, permanently occupied, densely populated settlement with monumental architecture and public infrastructure, and a hierarchical organisation that reflects a complex social and political structure. The researchers who published the findings described the Casarabe culture as a tropical low-density urbanism, a form of city life adapted to the specific conditions of the seasonally flooded Amazon. These were not compact-walled cities like those of medieval Europe or ancient Mesopotamia. They were dispersed urban landscapes in which residential areas, agricultural zones, managed forests, aquaculture facilities, and ceremonial centres were interwoven across a vast area, connected by roads and canals and organised around a hierarchical system of central and satellite settlements. And this is perhaps the most important lesson of the entire Amazonian story. Our definitions of civilization, of urbanism, of complexity, have been shaped by the experience of one particular part of the world, the arid and semi-arid regions of the Middle East, North Africa, and the Mediterranean, where the earliest Western recognised civilizations arose. In those environments, civilization looks a certain way. It has stone buildings, it has walls, it has dense concentrations of population in compact urban centres, it has writing systems and bureaucracies and standing armies, and all the other features that Western scholars learn to associate with civilized life. But these features are not universal requirements for civilization. They are specific adaptations to specific environments. Stone buildings make sense in places where stone is available and where protection from the elements requires heavy construction. Walls make sense in places where warfare is common and where defensible positions confer a military advantage. Dense urban centres make sense in places where water is scarce and populations must cluster around limited water sources. Writing systems and bureaucracies make sense in places where centralised states need to manage tax revenues and military operations across large territories. None of these conditions applied in the Amazon. Stone is rare in a landscape of alluvial sediment and forest soil. Walls are unnecessary in a landscape where the forest itself provides shelter and where the rivers provide natural transportation corridors. Dense urban centres are maladaptive in a tropical environment where dispersed settlement patterns reduce the risk of disease transmission and allow more efficient exploitation of the diverse resources available in different ecological zones. Writing systems are unnecessary in cultures that have developed sophisticated oral traditions capable of transmitting complex information across generations with remarkable fidelity. The Amazonian model of civilization is not a failed attempt at the Western model. It is a completely different model, one that is adapted to a completely different environment, one that emphasizes sustainability over extraction, integration over domination, harmony with the natural world over conquest of it. The Kasarabi cities of Bolivia, the garden cities of the Xingu, the managed landscapes of the Llanos de Mojos, the agroforestry systems of the Terra Firme, these are all expressions of a form of civilization that the Western world has been unable to see because it does not look like what we expect civilization to look like. We have been looking for pyramids and finding forests. We have been looking for palaces and finding gardens. We have been looking for empires and finding networks. And because we did not find what we were looking for, we concluded that there was nothing to find. That conclusion was wrong. It was spectacularly, embarrassingly, historically wrong. And the reason it persisted for so long is itself a story worth examining. The Western scholarly tradition from the Enlightenment onward developed a model of cultural evolution that placed European-style civilizations at the top of a hierarchy and all other forms of social organization somewhere below. Societies were ranked on a scale from savage to barbaric to civilized, and the criteria used to define civilization were drawn exclusively from the European experience. If a society had cities, it was civilized. If it had writing, it was civilized. If it had monumental architecture in stone, it was civilized. If it lacked these things, it was uncivilized, regardless of what it might have instead. This framework made it literally impossible for Western scholars to see Amazonian civilization for what it was. They were looking through a filter that only allowed certain shapes to pass through, and the shapes of Amazonian achievement, the managed forests, the enriched soils, the dispersed urban networks, the ecological engineering, simply did not match the template. They were filtered out, dismissed, ignored, or explained away as the insignificant activities of primitive peoples who had not yet figured out how to build proper cities. What was there was not nothing. What was there was something different. Something that worked. Something that lasted. Something that sustained millions of people for thousands of years without destroying the environment that supported them. Something that we desperately need to understand today as we struggle with the consequences of our own model of civilization, a model that is undeniably powerful, but that is also, with increasing urgency, proving to be unsustainable. It is a form of urbanism that Western scholars had never imagined, because it does not look like the cities they were trained to recognize. There are no stone buildings. There are no towering walls. There are no grid-planned streets or monumental temples built of dressed stone. There are instead earthen mounds and raised fields and canals and causeways and managed forests, all of it made from the same materials as the landscape itself, earth and water and wood and plants, shaped with such skill and maintained with such care that when the people who built them were gone, the jungle simply absorbed them back into itself, hiding the evidence of a civilization that had thrived for centuries. Now, I want to bring you back to the forest itself, to the question of how the ancient Amazonians managed and transformed the living landscape around them, because this is perhaps the most important and the most misunderstood aspect of the entire story. The Amazon rainforest contains approximately 390 billion individual trees belonging to roughly 16,000 different species. It is the most biodiverse forest on Earth, and for a long time, that biodiversity was cited as evidence that the forest was natural and untouched. How could human beings have managed a forest this complex? The answer, it turns out, is that they managed it precisely because they understood its complexity better than anyone else ever has. The ancient Amazonians were not farming in the way that we understand the term. They were not clearing the forest and replacing it with fields of a single crop. One of their most powerful tools was fire. Controlled burning, the deliberate setting of small fires at specific times of year, was one of the primary ways that ancient Amazonians managed the forest and the savanna. Fire cleared underbrush, recycled nutrients, stimulated the growth of new shoots that attracted game animals, opened the canopy to allow light-loving fruit trees to thrive, and maintained the boundaries between different ecological zones. The charcoal found in soil cores throughout the Amazon tells a story of continuous, widespread, deliberate burning that goes back thousands of years. This was not accidental fire, not wildfire out of control. The charcoal signatures in the soil are consistent with low-intensity, frequent burns, the kind of controlled fires that indigenous peoples around the world have used to manage their landscapes. In the transition zone between the Amazon forest and the Cerrado savanna, fire management was particularly important. By burning the grassland regularly, communities prevented the forest from encroaching on the open areas where they hunted and gathered, maintaining a mosaic of forest and savanna that maximized the diversity of resources available to them. The ring ditches found at many archaeological sites in the Amazon may have served partially as fire breaks, protecting settlements and their surrounding gardens from the controlled burns that swept across the landscape seasonally. They were practicing a form of land management that scholars have called agroforestry, or forest gardening, or managed mosaic agriculture. They were working with the forest, not against it, promoting useful species while suppressing competitors, creating clearings where desired plants could thrive while maintaining the overall structure and diversity of the forest as a whole. Let me give you some specific examples because the details are extraordinary. Take the Brazil nut tree, one of the most iconic species of the Amazon. The Brazil nut is a towering giant, reaching heights of over 160 feet, with a trunk so massive that it takes 4 or 5 people to encircle it with their arms. It produces hard woody pods the size of a cannonball, each containing 12 to 25 of the crescent-shaped nuts that you might find in a bag of mixed nuts at the grocery store. Brazil nut trees are scattered throughout the Amazon, but they are not distributed randomly. They occur in dense groves, clusters of dozens or even hundreds of trees growing close together, far more densely packed than you would expect if the trees had established themselves naturally. These groves occur preferentially on terra preta soils and near known archaeological sites. The conclusion is inescapable. The Brazil nut groves of the Amazon were planted by human beings, established and maintained over centuries as part of a managed forest landscape. The people who planted them are gone, but the trees remain, still producing nuts, still feeding the animals that depend on them, still standing as living monuments to the ecological intelligence of their planters. Or take the peach palm, the pupunha, one of the most important food plants in the Amazon. The peach palm produces clusters of starchy, nutritious fruits that can be boiled or roasted and eaten like potatoes. It is one of the oldest domesticated plants in the Americas, with evidence of cultivation dating back at least 9,000 years. Wild peach palms produce small fruits with large seeds and are covered in sharp spines that make harvesting painful and dangerous. But the domesticated varieties found throughout the Amazon produce large fruits with small seeds and have significantly fewer spines, the result of thousands of years of selective breeding by people who chose the best fruits for replanting generation after generation. The peach palm cannot reproduce on its own in the wild. It depends on human propagation. Every peach palm you see growing in the Amazon today is there because a human being planted it, or because it descended from a palm that a human being planted. The species itself is a living artifact of ancient Amazonian civilization. The same story repeats with cacao, the plant from which chocolate is made. Wild cacao originated in the upper Amazon region of South America, and genetic evidence suggests it was first domesticated there at least 5,000 years ago, long before it made its way to Mesoamerica, where the Maya and Aztec would later transform it into a ritual beverage for kings. The ancient Amazonians were drinking chocolate or something very like it, 3,000 years before anyone in Mexico ever tasted it. They were also managing stands of acai palms, the superfruit that has become fashionable in smoothie shops around the world. Acai palms grow in dense stands in the floodplain forests of the eastern Amazon, and archaeologists have documented terra preta deposits beneath many of these stands, suggesting that they were established and maintained by human communities that recognized the value of the palm's nutritious fruits and managed the surrounding forest to encourage its growth. Tucuma palms, whose fibrous fruits are rich in beta-carotene and whose fronds provide fiber for cordage and textiles. Bacuri trees, whose sweet, fragrant fruits are still prized in Brazilian markets today. Copaiba trees, whose resin has been used for centuries as a medicine, a sealant, and a fuel. Rubber trees, whose milky latex would not become commercially important until the 19th century, but which the ancient Amazonians had been tapping and using for waterproofing and bull-making for thousands of years. Each of these species tells the same story. Each one is more common near archaeological sites than in undisturbed forest. Each one bears the genetic signatures of long-term human management. Each one is a thread in the vast tapestry of the Amazonian garden. The domestication timeline for these species is itself a revelation. For decades, scientists believed that plant domestication in South America began in the Andes, not in the Amazon, because the Andean civilizations, the Inca and their predecessors, were the ones that Western scholars recognized as civilized. But genetic and archaeological evidence now places the origin of many important crop plants firmly in the Amazon basin, and at dates that are remarkably early. Squash was being cultivated in the Amazon by at least 10,000 years ago. Manioc cultivation dates back at least 8,000 years. Cacao domestication goes back at least 5,000 years in the upper Amazon. The bottle gourd, one of the most widely used plants in ancient America, with applications ranging from water containers to musical instruments to fishing floats, was domesticated in the Amazon and spread from there across the continent. Even maize, the crop that would become the most important food plant in all of the Americas, may have been first cultivated or at least significantly modified in the lowland tropics, before making its way to the highlands where it would later become the foundation of Mesoamerican and Andean civilizations. The Amazon was not a backwater receiving innovations from more advanced civilizations elsewhere. It was one of the primary centers of plant domestication in the world, comparable in importance to the Fertile Crescent of the Middle East, the Yangtze Valley of China, and the highlands of Mesoamerica. The people who lived here were among the first farmers on Earth, and the plants they domesticated, manioc, peanuts, cacao, rubber, tobacco, hot peppers, sweet potatoes, pineapples, and dozens of others, went on to transform cuisines and economies around the world. Every time you eat chocolate or peanut butter or pineapple or sweet potato fries, you are eating the legacy of ancient Amazonian farmers who selected and bred these plants thousands of years before any European knew the Americas existed. Every time you put rubber tires on your car or chew a piece of gum or wear a rubber-soled shoe, you're using a material that was first exploited by Amazonian peoples who understood its properties and developed techniques for processing it that the modern rubber industry still builds upon. The ancient Amazonians did not just feed themselves, they fed the world, and the world has barely even thanked them. A garden so large and so diverse that it encompasses an area the size of India. The result was a landscape that was simultaneously wild and cultivated, natural and artificial. Let me walk you through one of these managed forests, because the experience of being inside one is profoundly different from what most people imagine when they hear the word garden. You're walking through what appears to be pristine rainforest. The canopy above is closed and green, filtering the sunlight into soft, diffuse patterns that dance across the forest floor. The understory is relatively open, not the impenetrable tangle of vines and shrubs that movies depict, but a park-like space where you can walk freely between the trunks of large trees. The air is cool and humid, scented with the complex perfume of 100 different plant species. Birds call from the canopy above. A butterfly the size of your hand, its wings iridescent blue, drifts past at eye level. Nothing about this scene suggests human management, but if you know what to look for, the signs are everywhere. That tall tree ahead of you, the one with the straight smooth trunk and the spreading crown, that is a Brazil nut tree, and it is growing in a cluster with 5 other Brazil nut trees, a density that is statistically impossible without human intervention. The palm trees that line the trail, their trunks bristling with the scars of old frond bases, those are peach palms, and every single one of them was planted by a human hand. The small clearing to your right, where sunlight penetrates to the forest floor and tangle of vines bears clusters of dark purple fruits. That is cacao, growing in the dappled shade that it prefers, in a spot where someone, perhaps 1,000 years ago, cleared a small opening in the canopy and planted a few seeds. The large tree with the buttress roots, its branches laden with clusters of small hard fruits, that is a tucuma palm, whose fruits are rich in oil and whose fibres can be woven into some of the strongest cordage in the natural world. The vine climbing the trunk of a nearby tree, its woody stem as thick as your arm, that is ayahuasca, a plant that occupies a central place in the spiritual life of many Amazonian peoples, and whose presence here, growing conveniently beside a well-used trail, is almost certainly the result of deliberate planting. Every few steps you encounter another useful species, a tree whose bark can be brewed into a tea that reduces fever, a shrub whose leaves repel insects, a vine whose sap can be used as a fish poison, a palm whose fronds provide excellent thatching material. The forest is a pharmacy, a hardware store, a grocery, a textile mill, and a spiritual sanctuary, all in one. And all of it was planted, or at least encouraged, by people who understood the forest so intimately that they could reshape it without destroying it, enhancing its productivity while maintaining its diversity, turning a wild ecosystem into a managed one so skillfully that the management itself became invisible. A seamless blend of human intention and ecological process that produced abundant food, medicines, building materials, fibres, dyes, and 1,000 other products while maintaining the forest's essential ecological functions, its ability to produce oxygen, to store carbon, to regulate rainfall, to cycle nutrients, to support the astonishing diversity of life that makes the Amazon unique among the world's ecosystems. If you are enjoying this journey into the hidden history of the Amazon, take a moment to subscribe to this channel and leave a comment. Was it the Terra Preta that surprised you most? The hidden cities, the forest gardens? Every comment helps this channel reach more people who are curious about the real story of the ancient Americas. Now let your breathing slow just a little more. Let the weight of your body press deeper into whatever surface supports you. The Amazon at night is a world of sound. The daytime chorus of birds gives way to a nighttime symphony of frogs and insects, a pulsing rhythmic wall of sound that rises and falls in waves, each species adding its voice to the collective song. Tree frogs trill in high, clear notes from the branches above. Cicadas drone in long, sustained buzzes that seem to vibrate the air itself. Somewhere in the darkness, a nightjar calls, a haunting two-note whistle that repeats at intervals like a slow heartbeat. And beneath all of these sounds, beneath the biological cacophony, there is another sound, softer, deeper, harder to identify. It is the sound of the forest growing, the sound of roots pushing through soil, of leaves unfurling, of water being drawn up through trunks and released into the air through millions of tiny pores on the undersides of leaves. But before I tell you about the flying rivers, let me describe the liquid river itself, because the Amazon River is one of the most extraordinary features of the natural world, and the people who lived along it developed a deep and intimate understanding of its rhythms. The Amazon carries more water than any other river on Earth, roughly 1/5 of all the fresh water that flows into the world's oceans. At its widest point during the flood season, the river stretches more than 30 miles across, so wide that you cannot see the far bank, so wide that it creates its own waves, its own tides, its own weather patterns. The water is not clear. It is brown, stained by the sediment and dissolved organic matter carried from the Andes and from the thousands of tributaries that feed into it, each tributary draining its own vast watershed. The Amazon basin contains two fundamentally different types of landscape, and the ancient Amazonians developed different strategies for living in each one. The Várzea, the seasonally flooded lowlands along the major rivers, is a landscape of astonishing fertility. Every year, when the rains come to the Andes and the rivers rise, the Várzea floods, and when the waters recede, they leave behind a fresh layer of nutrient-rich silt that fertilizes the soil naturally. The Várzea is where the largest and most complex Amazonian societies developed, the riverbank towns that Orellana described, the dense populations that produced the elaborate pottery of the Marajoara and the Tapajós. The annual flood cycle provided both abundant fish, which concentrate in the floodplain lakes as the waters recede, and naturally fertilized soil that could support intensive agriculture without the need for terra preta. The terra firma, the upland forests that never flood, is a different world entirely. The soils are poor, the natural fertility is low, and the resources are more dispersed. But the terra firma peoples were no less ingenious than their Vasia counterparts. They were the masters of terra preta, the forest gardeners, the agroforesters who transformed vast tracts of nutrient-poor forest into productive managed landscapes. They developed extensive trail systems connecting their communities through the forest, maintained orchards and gardens in the midst of what appeared to be unbroken jungle, and practiced a form of land management that was so light in its touch, so harmonious with the natural processes of the forest, that it left the least visible archaeological footprint, the hardest evidence to find, the most easily dismissed by skeptics who were looking for cities and finding only trees. Between the Vasia and the terra firma, other environments supported their own distinctive cultures. The Igapo, the black water, flooded forests along certain tributaries, supported communities that specialized in aquatic resources. The Campinarana, the white sand forests with their distinctive low canopy and high biodiversity, were managed by communities that exploited their unique ecological characteristics. The Cerrado, the tropical savanna that borders the Amazon to the south and east, was managed with fire by communities that used controlled burning to maintain open grasslands productive for hunting and gathering. Each environment presented its own challenges, and the people who lived in each one developed their own solutions, their own technologies, their own forms of ecological management. The diversity of Amazonian cultures was a reflection of the diversity of Amazonian environments, and the ingenuity of Amazonian peoples was expressed in dozens of different ways, across dozens of different landscapes, all of them linked by trade networks and cultural connections that spanned the entire basin. The Amazon produces so much water vapor through this process of transpiration that it creates its own weather. These flying rivers are one of the most extraordinary phenomena on Earth. Each large tree in the Amazon pumps hundreds of gallons of water from the soil into the atmosphere every day through transpiration. The process by which water is absorbed by the roots, pulled up through the trunk, and released as vapor through the leaves. Multiply that by 390 billion trees, and the numbers become almost incomprehensible. The Amazon forest releases approximately 20 billion tons of water vapor into the atmosphere every single day, more water than the Amazon River discharges into the Atlantic Ocean. This moisture does not simply dissipate. It forms massive atmospheric rivers that flow westward across the continent, carried by prevailing winds until they hit the wall of the Andes Mountains and are forced upward, cooling and condensing into rain that falls on the western slopes of the Andes, feeding the glaciers and rivers that in turn flow back down into the Amazon basin, completing a vast hydrological cycle that the forest itself creates and maintains. Without the forest, the flying rivers would cease. Without the flying rivers, the rainfall across much of South America would decline dramatically. Without the rainfall, the forest itself would begin to die. It is a system of breathtaking circularity, a self-sustaining engine of water and life that has been running for millions of years, and that the ancient Amazonians understood well enough to work within without disrupting. They took water from the rivers and the rains and they returned it to the soil. They cleared patches of forest and they let other patches grow back. They managed the cycle, participating in it, becoming part of its rhythm, never taking more than the system could regenerate, never pushing the engine past the tipping point beyond which it could not recover. That is a lesson we have not learned. The modern deforestation of the Amazon is pushing the system toward exactly that tipping point. Scientists estimate that if between 20 and 25% of the Amazon forest is destroyed, the flying rivers will weaken to the point where the remaining forest can no longer sustain itself. The forest will begin to die back on its own, converting from rainforest to savanna in a process that would release billions of tons of carbon into the atmosphere and fundamentally alter the climate of the entire southern hemisphere. We are currently at approximately 17% deforestation. The tipping point is terrifyingly close, and the ancient Amazonians, who managed this landscape for thousands of years without approaching anything like that threshold, have lessons to teach us that we cannot afford to ignore, generating what scientists call flying rivers, invisible rivers of moisture that flow through the atmosphere above the canopy, carrying more water than the Amazon River itself carries in its channel below. The forest makes its own rain. And the people who lived here for thousands of years understood this. They understood it not in the abstract scientific terms that we use today, but in the practical, intimate, lived experience terms of people who depend on the forest for everything, for food, for water, for shelter, for medicine, for meaning. They knew how to process manioc, the starchy root that was the staff of life for most Amazonian peoples, a plant so central to their civilization that it deserves special attention. Manioc is an extraordinary crop. It grows in poor soil, tolerates drought, produces enormous yields, and stores energy so efficiently that a single hectare of manioc can feed more people than a hectare of almost any other crop. But there is a catch. Most varieties of manioc are toxic. The roots contain cyanogenic glycosides, compounds that release hydrogen cyanide, one of the deadliest poisons known, when the plant tissue is damaged. Eating raw or improperly processed manioc can cause cyanide poisoning, which can be fatal. The ancient Amazonians solved this problem with a processing technique so sophisticated that it would not be out of place in a modern food chemistry laboratory. They peeled the roots, grated them on boards studded with small sharp stones or thorns, creating a coarse pulp. They then placed the pulp in a long tubular press called a tipiti, a woven basket that could be stretched to squeeze the pulp and extract the toxic liquid. The liquid was collected and set aside, not discarded, because the starch that settled out of it could be dried and used as a flour called tapioca. The remaining pulp was spread on large flat ceramic griddles and toasted over a fire, creating a flat dry bread called casabe that could be stored for weeks or months without spoiling, a crucial advantage in a climate where most foods rot within days. But that is not all. The toxic liquid that was squeezed from the manioc pulp was itself useful. When boiled for several hours, the cyanide evaporates, and the remaining liquid becomes tucupi, a flavorful sauce that is still a staple of Amazonian cuisine today. When tucupi is further reduced and mixed with peppers, it becomes tucupi com pimenta, a condiment so delicious that it has survived the destruction of the civilization that invented it, and is still served in restaurants across the Brazilian Amazon. The entire manioc processing chain, from toxic root to edible bread to flavorful sauce, represents a masterpiece of food technology, a multi-step chemical process that transforms a deadly poison into a nutritious staple food and a gourmet condiment while wasting nothing. And this is just one example of the food processing genius of the ancient Amazonians. They also developed techniques for fermenting beverages from dozens of different fruits and roots. They smoked and dried fish and meat using techniques that preserved protein for months in a tropical climate. They extracted oils from palm fruits using presses and fire. They processed Brazil nuts into a rich milk and a calorie-dense flour. They fermented cacao into a chocolate beverage that was consumed in ceremonies and feasts. The culinary traditions of the ancient Amazon were not simple. They were among the most sophisticated in the world, reflecting thousands of years of experimentation and refinement by people who understood the chemistry of food at an intuitive level that modern science is only beginning to appreciate. They knew which trees attracted rain and which trees held the soil. They knew which plants healed fevers and which plants poisoned fish so they could be easily caught. They knew which fruits ripened in which season, and which animals ate which fruits and which routes those animals followed through the forest. They carried in their minds a map of the forest that was simultaneously a botanical encyclopedia, a pharmacological database, an ecological model, and a spiritual geography. And they used that knowledge not just to survive in the forest, but to improve it, to make it more productive, more diverse, more resilient, more beautiful. The Amazon they created was better than the Amazon that nature alone would have produced. It was richer in useful species. It was more productive per acre. It was more resilient to disturbance. It was in every measurable way an improvement upon the natural baseline, achieved through thousands of years of patient, intelligent, ecologically informed management. But before I tell you about the destruction, let me tell you about the moment when Europeans first glimpsed what the Amazon had been. In 1542, a Spanish expedition led by Francisco de Orellana became the first Europeans to navigate the entire length of the Amazon River from the Andes to the Atlantic Ocean. The journey took 8 months, and the accounts left by the expedition's chronicler, a Dominican friar named Gaspar de Carvajal, describe a landscape that bears almost no resemblance to the Amazon that later explorers would encounter. Carvajal wrote about vast settlements stretching along the riverbanks for miles without interruption. He described towns with hundreds or thousands of inhabitants, plazas and roads and orchards and gardens visible from the river. He reported being attacked by fleets of war canoes, hundreds of them, manned by warriors so numerous that the Spaniards feared for their lives. He described a region he called the province of the Amazons, named after the female warriors of Greek mythology, where the towns were so large and so closely spaced that the Spaniards could barely find a place to camp without being within sight of a settlement. He wrote about roads leading away from the river into the interior, roads wide enough for several people to walk abreast, suggesting that the population extended far beyond the riverbanks. Let me paint a picture of what one of these riverbank towns might have looked like at its peak in the centuries before European contact. You are travelling by canoe along the Amazon mainstream somewhere near the modern city of Santarém, where the clear blue waters of the Tapajós River meet the muddy brown current of the Amazon. It is late afternoon, and the light is golden and rich, turning the river surface into a sheet of hammered bronze. Your canoe rounds a bend, and suddenly the riverbank before you is alive with human activity. The settlement stretches for miles along the bluff above the river, a continuous strip of houses and gardens and plazas that seems to have no beginning and no end. The houses are large, far larger than you might expect, with steep thatched roofs that overhang deep verandas where people sit and work in the shade. Some of the houses are enormous, communal longhouses that might shelter 50 or 100 people from a single extended family, their interiors divided into family spaces by woven partitions, their central areas open for cooking and gathering. The bluff itself has been modified, its face sculpted into terraces that step down to the water, each terrace supporting gardens or serving as a platform for drying fish in the sun. At the water's edge, dozens of canoes are drawn up on the sandy bank, some of them simple dugouts carved from single tree trunks, others much larger, war canoes or trading canoes capable of carrying 20 or 30 people and substantial cargoes. The river in front of the settlement is dotted with fish traps and weirs, ingenious constructions of stakes and woven barriers that funnel the current through narrow openings where nets or baskets catch the fish that are channeled toward them. Fish is the primary source of protein for the people here, and the Amazon provides it in staggering abundance. The rivers and floodplain lakes of the Amazon contain more than 3,000 species of freshwater fish, more than any other river system on Earth, and the people who live along the river have developed techniques for catching, processing, and storing fish that are among the most efficient in the world. On the bluff above, the sounds and smells of the town wash over you. The rhythmic thudding of manioc being processed, the grating and pressing and toasting that transforms the toxic root into edible bread, the smell of fish being smoked over slow fires, the flesh darkening and curing in the fragrant smoke, the sharper smell of fermenting chicha, a mildly alcoholic beverage made from fermented manioc or fruits that is the social lubricant of Amazonian life, consumed in vast quantities at feasts and ceremonies. Children are playing along the riverbank, their laughter carrying across the water. Dogs bark. Someone is shaping a pot from a coil of red clay, smoothing the surface with a wet stone, preparing it for the elaborate painted designs that will be applied after the first firing. This is not a primitive village. This is a town. A prosperous, well-organized, culturally sophisticated town, one of dozens that line the banks of the Amazon and its major tributaries for thousands of miles. The population of this single settlement might be 3,000 or 5,000 or more, and it is just one node in a vast network of communities that collectively number in the millions. He described warehouses full of dried fish and manioc and other foods, evidence of organized storage systems capable of feeding large populations. For centuries, Carvajal's account was dismissed as fantasy, the exaggerations of a man trying to make his expedition sound more impressive than it was. The Amazon was empty, scientists said. It could not have supported the large populations that Carvajal described. His account must have been fabricated or wildly exaggerated. But in the light of what we now know about Terra Preta, about the managed forests, about the raised fields and causeways of the Llanos de Mojos, about the garden cities of the Singu and the urban networks revealed by LiDAR, Carvajal's account no longer seems exaggerated at all. It seems, if anything, like a modest description of what was actually there. The Amazon that Orellana travelled through in 1542 was a populated landscape, a network of towns and cities, and managed forests and agricultural systems that supported millions of people. The most careful recent estimates suggest that the pre-contact population of the Amazon basin may have been between 8 and 10 million people, and some researchers have proposed figures as high as 20 million. 20 million people, living in a landscape that Western science would later declare incapable of supporting anything more than small bands of hunter-gatherers. When later European explorers travelled the Amazon in the 17th and 18th centuries, they found a very different landscape. The riverbanks were empty. The great towns that Carvajal described had vanished. The forests had grown back over the ruins of settlements and fields and gardens. The population had been decimated, not by European weapons, but by European diseases, smallpox and measles and influenza and typhus, and dozens of other pathogens to which Amazonian peoples had no immunity. The diseases raced ahead of European settlement, spreading from community to community through the same trade networks that had connected Amazonian peoples for thousands of years, reaching populations that had never seen a European face. By the time European explorers arrived in many parts of the Amazon, the people were already dying or already gone. The great civilization of the Amazon did not fall to a conquering army. It fell to invisible enemies, microscopic organisms that travelled faster than any human messenger, that killed more efficiently than any weapon, that destroyed in decades what had taken millennia to build, and then it was all destroyed. Not the forest itself, but the people who had created and maintained it. When European diseases reached the Amazon in the 16th and 17th centuries, they killed an estimated 90% of the population. 90%. Imagine that. Imagine a world in which 9 out of every 10 people you know suddenly die. Imagine the knowledge that dies with them, the ecological expertise, the botanical knowledge, the agricultural techniques, the spiritual traditions, the stories and songs and ceremonies that gave meaning to the relationship between the people and the forest. All of it, gone in a generation. Recent research has suggested that the depopulation of the Americas after European contact was so massive, involving the death of perhaps 50 to 60 million people across both North and South America, that it had a measurable effect on the global climate. With millions of acres of managed farmland and gardens suddenly abandoned, forests grew back over the cleared land, absorbing so much carbon dioxide from the atmosphere that global temperatures actually dropped slightly, contributing to the period of cooling known as the Little Ice Age that affected Europe in the 17th century. The death of millions of Americans literally changed the weather on the other side of the world. In the Amazon specifically, the collapse was catastrophic and swift. Communities that had maintained terra preta plots and managed forests for centuries vanished within a generation. The knowledge of which plants to tend and which to suppress, of when to burn and when to let the forest grow, of how to prepare terra preta and where to place it, all of this accumulated wisdom was lost as the elders who carried it died before they could pass it on. Young people who would have spent years learning from their grandparents instead found themselves orphaned in a depopulated landscape, surrounded by the ruins of a civilization they barely understood, trying to survive in a world that had been fundamentally altered by forces they could not see or comprehend. Imagine that silence. Imagine walking through a town that once held thousands of people and finding it empty. The houses are still standing, but the thatch is beginning to rot. The gardens are still growing, but no one is weeding them. The fish traps in the river are still catching fish, but no one is collecting them. The manioc plants are mature and ready for harvest, but no one comes to dig them up. The pottery drying racks are still loaded with half-finished vessels that will never be painted or fired. The children's toys are scattered in the plaza where they were dropped when the sickness came. And everywhere, the forest is creeping back in. Vines climbing the house posts, seedlings pushing up through the packed earth of the plaza, the straight edges of the gardens blurring as wild plants reclaim the borders, the canals silting up, the causeways washing away, the raised fields subsiding, the whole elaborate infrastructure of a civilization that took thousands of years to build dissolving in a matter of decades, absorbed back into the landscape as if it had never existed. Within a century of European contact, the Amazon had been transformed from one of the most densely populated and intensively managed landscapes on Earth into what appeared to be an empty wilderness. The transformation was so complete, so thorough, that the Europeans who arrived later genuinely believed that the forest had always been this way, that no one had ever done anything significant here, that the scattered handfuls of surviving indigenous people represented the sum total of what the Amazon had ever been. They were looking at a ruin and calling it a virgin forest. They were looking at a graveyard and calling it a Garden of Eden. The forest that remained was not a pristine wilderness. It was a post-apocalyptic landscape, a garden without gardeners, a managed ecosystem suddenly deprived of its managers. And without human management, the forest began to change. The useful species that had been promoted for thousands of years began to face increased competition from unmanaged species. The clearings that had been maintained by controlled burning began to close over. The trails that had connected communities began to disappear beneath new growth. The terra preta that had sustained productive agriculture began to be covered by leaf litter and forest debris. Within a few generations, the evidence of thousands of years of human management began to fade, absorbed back into the forest, hidden beneath the canopy, invisible to the European explorers and naturalists who arrived and saw only what they expected to see: an untouched wilderness, a primeval jungle, a green cathedral built by nature alone. And that is the story they told, a story that became the foundation of Western attitudes toward the Amazon for the next 500 years, a story that justified the destruction of indigenous peoples and their cultures because, after all, they had never done anything significant with the land. They were just primitive savages living in harmony with a nature they did not understand and could not control. Every part of that story is wrong. The people of the ancient Amazon were not primitive. They were brilliant. They were not passive inhabitants of the forest. They were its architects. They did not fail to build a civilization because the jungle was too hostile. They built a civilization that was so perfectly adapted to the jungle that it became invisible, hidden in plain sight, mistaken for nature by scientists who could not see past their own assumptions about what civilization is supposed to look like. The real lesson of the Amazon is not about the past. It is about the present and the future. The ancient Amazonians figured out something that we are still struggling to learn. They figured out how to build a prosperous, complex, enduring society without destroying the natural environment that supported it. They figured out how to be productive without being destructive. They figured out how to reshape the world without breaking it. And the tools they used to do this, terra preta, agroforestry, managed mosaics, water management systems, integrated urban and rural landscapes, are exactly the tools that scientists today are looking to as potential solutions for the environmental crises we face. Terra preta research is one of the most active areas of soil science today, as researchers try to recreate the ancient soil amendment process to restore degraded agricultural lands around the world. Agroforestry, the integration of trees and crops and livestock into a single productive landscape, is increasingly recognized as a more sustainable alternative to the monoculture farming that dominates modern agriculture. The managed mosaic approach, in which human settlements and agricultural areas are interwoven with natural habitats rather than replacing them, offers a model for development that preserves biodiversity while supporting human needs. Biochar, the modern term for the charcoal-based soil amendment that the ancient Amazonians invented thousands of years ago, is now the subject of hundreds of scientific studies and a growing industry. Researchers have demonstrated that adding biochar to degraded tropical soils can dramatically increase crop yields, while simultaneously sequestering carbon, removing it from the atmosphere, and locking it into the soil for centuries. A single hectare of terra preta contains approximately 250 tons of carbon per metre of depth, an enormous quantity of sequestered carbon that has been stable in the soil for thousands of years. If biochar could be produced and applied on a global scale, it could simultaneously address two of the most pressing environmental challenges of our time: soil degradation and climate change. The ancient Amazonians did not know about climate change. They did not know about carbon sequestration. They were not trying to save the planet. They were trying to feed their families. But in the process of feeding their families, they developed a technology that locked carbon into the soil at a rate that, if replicated today, could offset a significant fraction of global greenhouse gas emissions. The elegance of the solution is breathtaking. By converting organic waste into charcoal and incorporating it into the soil, the ancient Amazonians simultaneously solved three problems. They disposed of waste, they improved their soil, and they stored carbon in a stable form that persisted for millennia. No modern waste management system achieves all three of these goals simultaneously. The agroforestry practices of the ancient Amazonians are equally relevant to modern challenges. Around the world, conventional monoculture agriculture is degrading soils, destroying biodiversity, contaminating water supplies, and contributing to climate change. The alternative, as the ancient Amazonians demonstrated, is a form of agriculture that works with natural ecosystems rather than replacing them. An agriculture that maintains forest cover while producing food. An agriculture that enhances biodiversity rather than destroying it. an agriculture that builds soil rather than depleting it, an agriculture that sequesters carbon rather than releasing it. These are not utopian fantasies. They are descriptions of a system that actually existed, that actually worked, that actually sustained millions of people for thousands of years in one of the most challenging environments on Earth. The system was not perfect. No human system is, but it was immeasurably more sustainable than the industrial agriculture that is currently destroying the Amazon at a rate of millions of acres per year, replacing the most biodiverse forest on Earth with cattle pasture and soybean fields that degrade within a few years and must be abandoned for new clearings, in an endless cycle of destruction that is driving species to extinction, destabilizing the regional climate, and releasing billions of tons of carbon into an atmosphere that is already dangerously overloaded. The water management systems of the Llanos de Mojos are equally instructive. In an era when climate change is making floods more severe and droughts more prolonged in tropical regions around the world, the raised field and canal systems of the ancient Mojos offer a model for how human communities can adapt to seasonal flooding without fighting it. Instead of building dams and levees to hold back the water, the ancient Mojos people worked with the water, using it as a resource rather than treating it as an enemy, channeling it through their agricultural landscape in ways that enhance productivity rather than destroying crops. The same principle could be applied in flood-prone regions around the world today, from Bangladesh to the Mississippi Delta, if engineers and planners were willing to learn from the people who figured it out thousands of years ago. The ancient Amazonians were not just ahead of their time, they were ahead of ours. And the tragedy is not just that their civilization was destroyed. The tragedy is that the knowledge they possessed, knowledge that took thousands of years to accumulate, knowledge that could help us solve the most pressing environmental problems of our own era, was very nearly lost forever, dismissed as the primitive superstitions of savages by a colonial culture too arrogant to recognize genius when it saw it. But it was not entirely lost. These communities, though reduced to a fraction of their ancestral population, are the living inheritors of a knowledge tradition that spans thousands of years. Their elders carry in their memories encyclopedias of botanical knowledge that Western science is only beginning to catalogue. A single elder in an Amazonian community may know the uses of several hundred plant species, their medicinal properties, their seasonal cycles, their ecological relationships, their preparation methods, their spiritual significance. This knowledge is not written down. It is transmitted orally, from generation to generation, in the same way that the Hopewell astronomers of Ohio transmitted their knowledge of the lunar cycle, through patient teaching and careful listening, and years of apprenticeship in the forest itself. The pharmacological knowledge of Amazonian peoples is particularly extraordinary. The Amazon contains more than 80,000 plant species, and indigenous communities have identified medicinal uses for thousands of them. Curare, the muscle-paralyzing poison used on blowgun darts, is made from a complex mixture of plant extracts that must be prepared according to exact specifications to be effective. The preparation involves boiling the bark of certain vine species for hours, straining the liquid, reducing it to a thick paste, and applying it to the tips of darts that are then carefully dried. The chemistry is precise. Too little curare and the dart will not paralyze the prey. Too much, and the meat may be toxic to eat. The ancient Amazonians calibrated their dosage through centuries of trial and error, developing a pharmacological technology that Western science did not fully understand until the 20th century, when curare-derived compounds were adopted for use in modern surgical anesthesia. Quinine, the anti-malarial drug that made European colonization of the tropics possible, was discovered by Amazonian peoples long before any European ever suffered from malaria. They extracted it from the bark of the cinchona tree, a species that grows in the upper Amazon, and used it to treat fevers. When European colonizers learned about quinine from indigenous healers, they seized upon it as the key to surviving in tropical environments that had previously been death traps for Europeans. The irony is bitter. The people who discovered the cure for malaria were the same people who were being destroyed by the diseases that the Europeans brought with them. Rubber, which would transform the global economy in the 19th century and drive one of the most brutal episodes of colonial exploitation in the history of the Amazon, was first collected and processed by indigenous peoples who had been tapping rubber trees and using the latex for waterproofing, making balls and sealing containers for thousands of years. They understood the properties of the latex, the best techniques for tapping the trees without killing them, the methods for processing the raw latex into a usable material. All of this knowledge was appropriated by the rubber barons who descended upon the Amazon in the late 1800s, who enslaved and murdered tens of thousands of indigenous people to feed the global demand for rubber, and who never acknowledged that the entire industry was built upon indigenous knowledge and indigenous labour. The story repeats across dozens of products that the world now takes for granted: chocolate, vanilla, tobacco, peanuts, sweet potatoes, pineapples, avocados, cashews, passion fruit, papaya. All of these were domesticated by the peoples of tropical South America, their wild ancestors transformed over millennia of selective breeding into the productive varieties that now feed billions of people around the world. The ancient Amazonians were not just the gardeners of the forest, they were the gardeners of the world. Some of it survives in the practices and the oral traditions of indigenous communities that still live in the Amazon today. Some of it has been recovered by archaeologists and soil scientists and ecologists who have learned to read the clues that the ancient Amazonians left behind in the soil and the forest and the landscape. And some of it, perhaps the most important part, survives in the terra preta itself, that miraculous black earth that is still fertile after 7,000 years, still doing its job, still nurturing life, still waiting for someone to understand what it means and to learn from the people who made it. As your eyes grow heavier and your thoughts begin to soften and blur, let one last image settle in your mind. A forest at dawn, the first light filtering through the canopy in shafts of golden green, the air thick with the smell of earth and flowers and the faint sweetness of ripening fruit. Somewhere nearby, a river whispers over stones, the water dark and clear and cold, and beneath your feet, invisible but present, a layer of black earth, rich and deep and full of life, made by hands that are gone now but whose work endures. The forest remembers them, the soil remembers them, the trees that they planted and tended still stand, still bear fruit, still feed the animals and the birds and the people who live here now. The peach palms still bear fruit in the clearings where ancient hands planted them. The Brazil nut trees still tower above the canopy, their crowns spread wide to catch the tropical sun, their roots sunk deep into terra preta that has been fertile for 7,000 years. The acai palms still cluster along the riverbanks in groves that were established by people whose names we will never know, but whose care for the future we can still taste in the sweet dark purple of the fruit. The cacao trees still grow in the dappled understory, their heavy pods still hanging from their trunks like gifts from a world that existed long before ours and that may, in some form, continue long after ours is gone. And the terra preta still works, still black, still fertile, still harbouring the microbial communities that were established by human activity thousands of years ago. If you were to plant a seed in that soil tonight, it would grow faster and stronger, and more abundantly than a seed planted in the natural soil just a few feet away. The ancient engineers who created that soil are gone, but their engineering persists, still functioning, still productive, still waiting to nourish whatever seed is placed in its care. There is something deeply comforting in that thought as you drift towards sleep. The idea that what we create with care and intelligence and love can outlast us by millennia. The idea that the earth can hold our best intentions long after our bodies have returned to it. The idea that the good we do in our brief time here can echo forward through centuries, through millennia, through geological ages, quietly sustaining life that we will never see, feeding mouths that will never know our names, enriching soil that our hands will never touch again. Let that thought carry you into sleep. Let the sounds of the forest, the frogs and the insects and the gentle whisper of water moving over stones be your lullaby tonight. Let the darkness behind your eyelids be the darkness of the forest at night, warm and alive and full of the quiet breathing of millions of organisms going about the business of living, each one connected to every other, each one a thread in the vast web that the ancient Amazonians understood so well, and that we're only now beginning to see. Your breathing has slowed, your muscles have softened, your mind is drifting, releasing the thoughts of the day, letting them fall away like leaves from a canopy, spiraling slowly downward, catching the light for one last moment before settling on the forest floor where they will decompose and become soil and nourish the roots of new thoughts that will grow tomorrow. The garden persists even without its gardeners. And perhaps that is the most hopeful thing of all, that what we create with patience and wisdom and love can outlast us, that the good we do can endure for millennia after we are gone, that the earth remembers even when the world forgets. Sleep well tonight, and when you wake, carry this knowledge with you, The Amazon is not a wilderness, it is a masterpiece, and the people who created it deserve to be remembered among the greatest minds and the most skilled hands that the human species has ever produced. Let the last tension in your body dissolve. Feel your shoulders drop, feel the muscles around your eyes soften. Feel the weight of your jaw releasing, your tongue resting gently in your mouth, your hands uncurling, your fingers relaxing against the surface where they rest. You are safe, you are warm, you are held by the same earth that held the ancient Amazonians, the same earth that they enriched with their care, the same earth that remembers every hand that touched it, every seed that was pressed into its surface, every fire that was tended on its breast. The night sounds of the Amazon are the oldest lullaby on earth. These same frogs have been singing these same songs for millions of years. These same insects have been humming in these same frequencies since long before any human being existed to hear them. And yet somehow the sound feels personal, feels intimate, feels like it was composed specifically for this moment, for you, for this night, for the passage from waking to sleep that you are making right now. The ancient Amazonians had a word, or rather many words in many languages, for the state of being that exists between waking and dreaming, the liminal space where the boundaries between the self and the world begin to dissolve, where the forest speaks and the dreamer listens, where the visible and the invisible, the material and the spiritual, the human and the more than human, all merge into a single flowing reality. You are entering that space now. The images from tonight's journey are arranging themselves behind your eyelids, like scenes from a half-remembered dream. The black earth crumbling between your fingers, the towering Brazil nut trees planted by forgotten hands, the raised fields of the Llanos de Mojos stretching to the flooded horizon, the geoglyphs of Acre, perfect circles cut into the red earth, the LiDAR images revealing cities hidden beneath the canopy, the ceramic art of the Marahuara, its spiraling designs encoding knowledge that we have not yet learned to read, the flying rivers flowing overhead, carrying more water than the Amazon itself, the causeway stretching straight and sure across the flood, connecting communities that chose to be connected, linking people who chose to share their lives and their knowledge and their vision of what the world could be. All of it is settling into your memory now, becoming part of you, becoming part of the story that you carry within you, the story of what human beings are capable of when they choose wisdom over power, patience over haste, harmony over domination. Rest now. The forest is quiet. The river is whispering. The ancient earth is warm beneath you, black and rich and alive with the microscopic communities that have been working tirelessly for 7,000 years, converting waste into nourishment, death into life, the past into the future. The charcoal that a woman placed in this soil before the pyramids of Egypt were built is still trapping nutrients tonight. The pottery fragment that a child dropped into a cooking fire 3,000 years ago is still providing habitat for the bacteria that keep this soil alive. The bone meal that was mixed into the earth during a feast to celebrate a harvest 5 centuries before Christ was born is still slowly releasing its phosphorus, still feeding the roots of trees that were not yet seeds when the feast was held. Time works differently in Terra Preta. It does not pass, it accumulates. Every generation that contributed to this soil is still here, still present, still participating in the ongoing miracle of fertility that they created. And in that sense, the people of the ancient Amazon are not gone at all. They are right here, beneath our feet, in the soil they made, in the trees they planted, in the forest they designed, in the garden they left behind for us to discover and to wonder at, and, if we are wise enough, to learn from, waiting with infinite patience for the world to finally understand what was built here, in the green heart of a continent, by people who knew that the greatest civilization of all is one that the forest itself cannot tell apart from nature,